Okay, we are continuing with the further maths chapter summaries, and this is for chapter 4, roots of polynomials. Now, I'm always going to say this, it is not possible for these chapter summaries to cover all of the possible ways that examiners can assess the topic. It is here just as a refresher. Make sure that you are also looking at exam questions. Now, it's worth noting that these chapter 4 techniques can be used a lot in complex numbers questions, and likewise, you could use some of the complex numbers techniques that we've learned so far in these kinds of questions. I'm pretty much going to focus on just this style of approach, but you can use a mixture of them. So if you answer these questions in a different way to me, that is absolutely fine that we've got here. So these are the kind of summaries here. When we have these things as roots, the letters A, B, C, D, and E, those are the coefficients of a polynomial, like ax squared plus bx plus c, etc. And these are the kind of summaries that we have of the roots. If you add all the roots together, the sum of the roots is minus b over a, the sum of the pairs is c over a, the sum of the triples is minus d over a, and if you take all of the roots and multiply them together, it is e over a for a quartic that we have here. So the pattern is they're all being divided by a, and then we start with a negative b, then a positive c, then a negative d, then a positive e. And the way I kind of do these is I always kind of like annotate the question with these facts that we've got here to kind of extract the information. So for this first question, it tells us that given that 5 plus I is one root of this quartic equation, find the three other roots and the values of p and q. So I am actually going to just go straight in and use some of these facts that are over here, and I like to annotate it straight above this. So I'm going to remind myself that this one is to do with the sum of the roots, the next is to do with the sum of the pairs, the next is to do with the sum of the triples, and the last one will be associated with alpha, beta, gamma, and delta all multiplied together. I will just write down this will be minus b over a, c over a, minus d over a, and e over a. So it just really helps me see that these things are all going to be associated with each other when I extract that information. Now, you've probably noticed one other thing. They've told us that 5 plus I is one of the roots, so you should already know that one of the other roots is going to be 5 minus I, because in chapter 1 with complex numbers, we talked about those complex conjugate pairs that we've got here. So we want to find these three other roots. I'm actually going to write down some of these facts, okay? I'm going to write down that the sum of the roots is equal to minus b over a. The b is minus 11, so it'll be 11 over that coefficient, which is just 1. So the sum of the roots is 11. And then I think the other one that's going to be the most useful is this one here where we've got all four of them. I'm going to leave these ones for now because I don't know p and I don't know q, so this information is not going to be as useful. But this one and this one are some good starting points. So I also know that alpha, beta, gamma, delta, when you multiply all of those together, you get e over a, which is just going to be minus 156. A in this case is just 1, so it's just going to be minus 156 over 1. So we've said that one of the roots is 5 plus I. That must mean that another root is going to be 5 minus I. And then our other ones are going to be gamma and delta that we've got here. So the sum of them is 11. This means that if I do 5 plus I plus 5 minus I plus gamma plus delta, I'm going to get 11. Let's just get myself a little bit of extra space there like this, okay? You can notice that pretty much all the time, I think, these imaginary parts are going to cancel, so that what we get left with is the 5 plus the 5, so let's say 10 plus gamma plus delta is 11, which tells me that these two roots, when they sum together, is 11 minus 10, which is 1. We're going to do the same thing with the alpha, beta, gamma, delta over here. We're going to have the alpha times the beta. That's my 5 plus I multiplied by my 5 minus I, multiplied by the gamma and the delta is minus 156. However you want to calculate this, manually or by a calculator, it doesn't really matter. But I know it's going to be the 5 times 5, and the I times the minus I is going to be a 1. So it's a 25 plus a 1, which is 26. So 26 gamma delta is minus 156. I will do minus 156 divided by 26, which tells me that gamma delta is minus 6. And all I've got to do now is just solve this thing and this thing like a simultaneous equation. Plenty of ways of doing this. I'm probably going to just make one of these things the subject over here. Let's just erase that a little bit more carefully. So I'm going to say that delta is 1 minus gamma, and I'm going to substitute it into this part. So that's going to be gamma multiplied by 1 minus gamma is minus 6. So that's gamma minus gamma squared is minus 6. Looks like it's going to be a quadratic. So it's going to be gamma squared minus gamma minus 6. And I can actually factorize this, or I could put it on the calculator. It's going to be a gamma minus 3 and a gamma plus 2. So it's telling me that either gamma is equal to 3 or gamma is equal to minus 2. And then using that information, I can say, well, if gamma is equal to 3, then delta would be 1 minus 3, which is minus 2. Or, from this part, I drew that delta a little bit weird, let me just change that. It would be that delta is 1 minus 2, which is 3. But you see what happens here is we get the same pair. We get a 3 and a minus 2. We get a 3 and a minus 2, or we get a 3 and a minus 2. So it doesn't really matter. We haven't been asked to find exactly which one is which. We've just been asked to find all 4 of the roots that we've got here. So now what we can say is, hence, we've got all the roots. Hence, the roots are 5 plus I, 5 minus I, 3, and minus 2. So we've used these two facts, right? We used this one and we've used this one. We're now going to finish this question by finding out what P and Q are. You can do this in like a complex numbers chapter 1 kind of thing by like forming the quadratic, expanding all of the things, blah, blah, blah. But I'm going to kind of stick with this sort of roots of polynomial theme that we've got for this. So I'm now going to say, using this fact that we've got over here, I'm going to say that the sum of the pairs is equal to C over A, which is just going to be P over 1, or just equal to P. So this means that P is going to be equal to the sum of all of these pairs. I'm going to write them down, okay? It doesn't matter which one we're going to do. I'll say that delta is 3 and that gamma is minus 2. So when you're doing the sum of the pairs, you're writing all of the possible pairs of these things multiplied together. So you could just put this all in your calculator, but I'm going to show you this in a bit more detail just because it's a video. What I mean by putting it in your calculator is you could store these values as letters A, B, C, and D, and then you can find all of the pairs really quickly. But I'll show you the slightly longer way that I'm going to do this. So for the pairs, I'm going to have my 5 plus I with the 5 minus I. I would have the 5 plus I with the 3, and I would have the 5 plus I with the minus 2. And then I have my 5 plus I with my minus 2. So I've done this with this, this with this, and this with this. I'm now going to do this one with this, and this one with this, okay? So that is going to be my 5 minus I with the 3, and also my 5 minus I with the minus 2. And then my last pair that I've got is the 3 and the minus 2 together. You could put this all in the calculator if you want to. I'm going to expand it. I know already that these things here expanded to 26. We did that earlier on. And then I'm going to have a 15 and a 3i, a minus 10 and a minus 2i, a 15 and a minus 3i, a minus 10 and a plus 2i, and then a minus 6. And you'll notice these imaginary parts cancelling out like this. All that's left is to hopefully think I can type correctly. So it's 26 plus 15 minus 10 plus 15 minus 10 minus 6. And we get that P is equal to 30. Okay? Like I said, you could do it in a different way if you wanted to. It's just my preferred method for these. So now I know that, I'm going to use this one. This is the fact for Q, right? That the sum of the triples, alpha, beta, gammas, is going to be equal to minus D over A. That's going to be equal to minus Q over A. So minus Q is equal to basically multiplying 3 of them and leaving 1 of them out. So when I multiply 3 of them, it's going to be this one, and I'll leave the last one out. I'm then going to have this one, and I will leave the third one out, so it'll be with a minus 2. I'm then going to have the alpha, and that's going to multiply with the 3 and the minus 2. And then I'm going to leave out just the alpha, so it's going to be the 5 minus I, the 3, and the minus 2. We should be able to calculate this pretty quickly, because earlier, do you remember we said this was 26? So this is going to be a 26 times by 3, a 26 times by minus 2. And then for this part, this is a minus 6. So I'm going to multiply these things by minus 6, okay? That means it is going to be a minus 30 and a minus 6i. And then again, this is a minus 6 with that bracket. So that's going to be a minus 30 and a plus 6i. As usual, the imaginary parts are going to cancel, and I can just type into my calculator 26 times 3 minus 26 times 2 minus 30 minus 30. And we get that minus Q is equal to minus 34, which means that Q is equal to 34. So we got that Q was 34, P was 30, and we got all of those roots. Like I said, try it in a different method. You might come up with a different way of doing this, but you should still come up with those same values that I have done here. Okay, we're now going to look at some expressions relating to the roots. Now, it's these kind of questions down here. They're sometimes asked as a different kind of style of question. If you want, you can try and memorize these things. I personally don't do much memorizing of these things. I find them very hard to get stuck in my head, but I will try and show you a bit about about how we might be able to remember these things. So for the reciprocals, if they wanted you to find 1 over alpha plus 1 over beta for a quadratic, it ends up as the sum of the roots over the two roots multiplied together. If it was for a cubic like this, well, it actually ends up as a similar structure to the one that's on the left, where you have the top part would be, let's make my pen a little bit thinner, the top part would be the sum of the pairs, and the bottom part would be all of them multiplied together. In other words, the numerator is like 1 degree like lower, like there's just one root here and there's 2 here, there's 2 roots here and there's 3 roots here. So if it was 1 over alpha, 1 over beta, 1 over gamma, 1 over delta, it would be the sum of alpha, beta, gamma on the numerator and alpha, beta, gamma, delta in the denominator. So the numerator is 1 less than the denominator. The sums of the squares, it is this one. If you want to find alpha squared plus beta squared, you do this. It is exactly the same formula for cubics and quartics. So you do the sum of them, and it's 2 minus the sum of the pairs. It always looks like this. However, the sum of the cubes is very horrible to remember. We only need to do the sum of the cubes for quadratics and for cubics. If you want, you can try and remember these things. I might put them on like a flashcard and look at them just as I was going in. They are similar to each other. This one, though, has this extra part that we've got here. I think I might have typed that part in wrong. I think that needs to say 3 alpha beta gamma. So I will make sure that that is changed in the PDF for when you go to look at that. It's just a slight typo for that one that we've got there, okay? So I'm probably not going to use these. They are here, though, as part of your thing to remember. I'm probably going to do them just in the way I'd maybe approach it myself in the exam. So it says the roots of this equation are alpha, beta, and gamma. Without solving the equation, determine the value of this thing. Okay, we've got 3 over alpha, 3 over beta, and 3 over gamma. Well, like before, I'm going to say this one is to do with the sum of the roots. Let's just zoom in. It's the sum of the roots, the sum of the pairs, and that's alpha, beta, gamma. I remind myself this is minus b over a, c over a, minus d over a, so that I can very clearly say that the sum of the roots is minus 13 over 3, in other words, 13 over 3. The sum of the pairs is just 25 over 3, and all 3 of those roots is going to be minus 7 over 3, which is just 7 over 3 for this, okay? Let's just put these over here so I've got a bit more space. Okay, part A of this. A is 3 over alpha plus 3 over beta plus 3 over gamma. Now, they need to have a common denominator, which is clearly going to be the alpha, beta, gamma. If this one needs to get the alpha and the beta gamma, it needs to be multiplied by the beta gamma. So it's 3 beta gamma. The next one needs the alpha delta, and the last one needs the alpha beta. So we can see that the numerator is 3 lots of the sum of the pairs, and the denominator is alpha, beta, gamma. And you can see it resembles this one up here, but of course we've got that extra 3. So it's just a matter of subbing in these key facts that we've got written along the top. That is 3 multiplied by 25 over 3, divided by all 3 of them, which is 7 over 3. I don't even like using a calculator for this, so these 3's are going to cancel. So it's 25 over 7 over 3. I can multiply the top and bottom by 3. That is going to be 75 over 7. Obviously, check it on a calculator if you want to. Now, B is this one. Have you noticed the kind of sneaky thing that I've done for this? These are written the other way around. So I'm going to make my life a little bit easier. I'm going to say that alpha minus 2, beta minus 2, gamma minus 2, 2 minus gamma, can be written. I'm just going to take a negative out of this one. I just prefer it looking all the same way. So we're going to have it with an alpha minus 2, a beta minus 2, and then a gamma minus 2. You don't have to take that negative out if you don't want to. And then I'm just going to go about expanding all of this and seeing if I can relate it to the above expressions. So let's do this first bracket. That will be my alpha beta. There will be minus a 2 alpha, minus a 2 beta, and plus a 4. And that needs to be multiplied by gamma minus 2. So much algebraic heavy lifting, I say, in these things. So much multiplying out and stuff. So I'll do everything in the first bracket by the gamma. So that's alpha beta gamma, 2 alpha gamma minus 2 beta gamma plus 4 gamma. And then I'll do everything multiplied by minus 2. So that will be minus 2 alpha beta plus 4 alpha plus 4 beta minus 8. Let's close that bracket off. So I wonder if we can summarize everything that's in here. We've got an alpha beta gamma, and then we have a 2, minus 2, a minus 2, and a minus 2. That means we've got minus 2 of the pairs, and then we've got 4 of those ones. That's just 4, the sum of the roots. And at the end, we have a minus 8. So it just comes now an option of just writing in those key facts at the top. So that was 7 over 3. We then have minus 2 times by 25 over 3 plus 4 times by 13 over 3 minus 8. Let's get it all in the calculator and hope that we've not made any crazy mistakes. So that's 7 thirds minus 50 thirds plus 52 thirds minus 8. Make sure I negate the answer, and we get that it is equal to 5, okay? Right, what have we got for the last one? Alpha squared plus beta squared plus gamma squared. Now, if we want to, we could just use this standard formula that we've got up here, and I'm going to just very quickly show you where that comes from. It comes from doing alpha plus beta plus gamma all squared. And this method I wanted to show you just because it can be really quick for doing these things. If I was going to do alpha plus beta plus gamma squared, you can do this grid method for multiplying them out. You get your alpha squared, your beta squared, and your gamma squared. That gives you an alpha beta here and an alpha beta here, an alpha gamma here and an alpha gamma here, a beta gamma here and a beta gamma here. So what we can see is that alpha squared plus beta squared plus gamma squared is alpha plus beta plus gamma all squared minus 2 lots of these ones, okay? I'll show you what I mean by this. So I'll block this off here, okay? So alpha plus beta plus gamma all squared is alpha squared plus beta squared plus gamma squared. And you should notice that we've got 2 of the pairs. We've got 2 of the pairs plus 2 the sum of the pairs. And that is where this formula has come from, okay? The sum of the squares. Alpha plus beta squared is going to be this thing. It's the sum of the roots all squared minus 2 of these. So let's just write that down. My alpha squared plus beta squared plus gamma squared is the sum of the roots squared minus 2 alpha beta. Okay, the sum of the roots is 13 over 3. So it's 13 over 3 squared minus 2, the sum of the pairs, which is 25 over 3. And I've just about fitted it in one page. So it's 13 over 3 squared minus 50 over 3. That is 19 over 9. Give it a little line to show it's the same as the other ones. Okay. So last one that we do for roots of polynomials is this thing called transformations of roots. So they've told us here that we have this cubic equation. It has roots alpha, beta, and gamma. And again, without solving the equation, determine a cubic equation whose roots have been transformed to alpha minus 1 over 2, beta minus 1 over 2, and gamma minus 1 over 2. Give your answer in this particular new form where you have integers for the coefficients. So the technique we use for this is let's just replace alpha or beta or gamma, these things here. Replace these parts with an x. Let w equal this transformed root expression. Rearrange it to find out what x is. We can then substitute it back into here. And then we just expand and simplify. This is usually sort of one of the easier questions, but it is very easy to make a mistake. So we're saying that the new root, w, are these ones. It's the old root minus 1 over 2. In other words, it's the old root minus 1 over 2. So we've just done this part and this part. Let's rearrange for x. So that's 2w plus 1 equals x. All we need to do now is sub it in here. So it is going to be 2w plus 1 cubed minus 5 lots of 2w plus 1 squared minus 8 lots of 2w plus 1 minus 3 equals 0. Okay, this is where I'm going to go a bit speedy with the binomial expansion here, because I can do most of this in my head. If you want to take your time with it, obviously do that as well. But 2w plus 1 cubed, or the 2w cubed, is going to be my 8w cubed. I'm then going to have a 2w squared, which will be a 4w squared, but there's a binomial coefficient of a 3, so that's a 12w squared. And then we would have a 2w times by the binomial coefficient of 3, which is 6w, and then a 1. We then have minus 5 lots of 4w squared plus 4w plus 1, minus 16w minus 8 minus 3 equals 0. So just taking my time with this to try and not make any mistakes, because I find when you rush these things, or when you talk at the same time, is when you make some of these mistakes that you've got here. So I'm just expanding that middle bracket, and then I'm hopefully, as I've simplified those last two to a minus 11, I'm hopefully going to get all of these simplified correctly. So I've got my 8w cubed. For the squareds, I've got just the 12 minus the 20, that's minus 8. For the w's, I have a 6 minus a 20 and a minus a 16, that's minus 30w. And then for the constants, I have a 1, a minus 5, and a minus 11, which is minus 15 equals to 0. And I just want to double check that that is written in the form of what they wanted in the question. Yep, it's written in that form. All of them are integers. Nice and easy, and we should have got that right. Pretty tricky topic, I think. It's quite easy to make mistakes with this. And this one up here, where I was doing a lot of substitution over here, I do recommend knowing how to do this sort of stuff on your calculator so you can do it nice and speedy if you need to. Okay, good luck with all of your studies, and I hope to see you in another video sometime soon.